Hello, this is Jason with Boundless Home Solutions, and today I'm going to walk through how to troubleshoot and diagnose a ground fault circuit interrupt outlet that is tripping. I'm going to walk through the tools that you need, how to diagnose whether you have a bad appliance or a bad outlet, how to find the breaker to turn off to do it safely, and how to remove the old outlet and install the new one in a safe way. So let's get started. Here are some of the tools that I recommend that everybody have if they're going to be working on electrical circuits. Just a flat blade screwdriver. This is a circuit tester that you can plug in to make sure to check that the outlets are wired properly, and it also has a button to test ground fault circuit interrupt outlets. This is a voltage tester. It's just you can turn it on and wave it by the outlet, and it tells you whether it's a live circuit or not. These are helpful. These are just needle nose pliers, and you can either do needle nose pliers and a set of wire strippers and wire cutters, or these are electrical pliers that have everything built in. Electrical tape, of course, and the whatever outlet you're working with. Okay, if you've got a GFCI outlet that is tripping like this with some appliance plugged into it, first thing you want to do is determine is the appliance actually bad, because the GFCI outlets are designed as kind of a safety feature so that if you've got a grounding issue or loose connections in your appliance, it trips the circuit so that you don't have fires and other damage. First thing you want to do is make sure that your plug is all the way in, because just something as simple as a loose plug can cause the GFCI to trip. You also want to check the cord to make sure that there's no damage, frayed areas, or cuts in the cord, and then check the appliance over to make sure that there's no damage on that. The other thing you can do is plug something else into the outlet that you know is good, and just make sure that it works properly. And if you continue to have tripping of the outlet, then the outlet is probably bad. I didn't realize, and a lot of people don't know, that the GFCI outlets do go bad over time. They're designed to last about 10 to 15 years, and they can go bad quicker in certain situations, like if you have a washing machine or something else with a motor, like a refrigerator, something like that plugged in, that can cause the outlets to go bad in as little as 5 years or less, maybe, depending on the situation. So in this case, this outlet is more than 10 years old, so I'm pretty confident that it's the outlet that is bad. So this is a 15 amp outlet. You can tell because it's just got straight blade slots. The 20 amp outlets have a little sideways slot on one of the blades. And so you have to determine what type of outlet to replace it with. This is on a 20 amp circuit, and I'll show you how to determine if that's the case. But I know that this is a 20 amp circuit, and this is a 15 amp breaker. Now, typically you would not want to do that. Code does allow for a 15 amp GFCI on a 20 amp circuit. However, we do have outlets that are downstream of this that are 20 amp outlets. And so I am going to be replacing this outlet with a 20 amp outlet just so that everything matches and we have maximum capacity. Now we need to find the breaker box and the specific breaker that we need to turn off in order to do this job safely. So the first thing that you want to do is kind of assess the environment. Okay, are there any other critical things plugged in the house that absolutely need to keep running, like oxygen machines, CPAP machines, anything that is critical? Is there anybody else working on projects in the house? Keep in mind that as you're trying to determine which breaker to turn off, you might lose connection to Wi-Fi and other devices. You might have lights turning on and off. So just make sure that you're in a good situation to test which breakers need to shut off. Then you need to find the breaker box, and it's usually somewhere in the basement or the garage or utility room. Sometimes it's in a closet or a hallway, and sometimes in certain situations, people will hide it behind decorative doors or artwork or something. So you really should know where your breaker box is in your house so that in an emergency you can turn things off. And if you're doing work on outlets, you know where it is. Then you need to determine which specific breaker you need to shut off. Obviously, you could just shut off the whole power to the whole house, but ideally you can let everything else run and just isolate the specific circuit that you're working on. And the first thing you want to do is check the labels first. Hopefully your breaker box is labeled with which circuits are connected to which breakers. However, a lot of times whoever hooked it up didn't label it properly. You can have somebody help you, so they can be in the room where the faulty outlet is, and then you can go to the breaker box and start flipping breakers, and they can tell you when the thing has turned off. You can also plug in something into the outlet that is either loud or bright, or like a connected device that might be connected to your phone, so that when you turn the power off, that item turns off, and then you know that you've got the right circuit. The other trick that you can do, which is what I'm going to use today, is plug a long extension cord or something, because there's actually quite a distance between this outlet and the breaker. And I'm going to be doing this by myself. So I'm going to have a long extension cord, and then I can have a vacuum cleaner running. And as I'm testing the breakers, I will listen for the vacuum cleaner to turn off. There's also tools available for tracing circuits where you can plug it in to the outlet that you're working on and then just scan the breaker box, and it will let you know exactly which breaker to use. And I don't know how much those specifically cost, but those are kind of specialty tools. So let's get started and figure out which breaker we need to turn off. Alright, we found the breaker boxes, and I have my vacuum indicator running. Now we have to determine which breaker it is. This is a laundry room outlet, so we're going to be looking for something that says laundry room. I see a bunch of bathrooms. I see kitchen. This is a fairly well labeled box here. There's laundry room. So laundry room receptacles, you can see that says number 11. So then you go to your breakers and they're all numbered. So there's number 11. So it's a 20 amp circuit, number 11. Flip it off. My vacuum didn't turn off, so that's not the right circuit. We'll turn that one back on. There's really no other good options here. I tried a few of them earlier. So there's a secondary box in this situation, and this one is not labeled very well. So it's a process of elimination, and we've got some 20 amp circuits, we've got a 15 amp circuit. So I went through and tried these earlier actually, and I believe it's this one. So you hear the vacuum turn off, so you know that that is the breaker to the outlet that we are working on. So now I'm going to go test the circuit and make sure it is completely dead, and then we can start removing the old outlet and installing the new one. Now that we have the breaker turned off, we want to double check to make sure that there's no electricity flowing to this outlet so that we can work on it safely. And so to do that, I use this voltage sensor. This is a very handy tool. I highly recommend everybody have one of these. So you just push the button and you can stick it right in the slots of the outlet. You see it's not beeping. So I'll show you what it looks like on an outlet that does have power. It'll beep like that. So you know that that outlet has power. The one that we are working on does not. So let's safely remove it now. So now that the outlet is accessible, you can, for one thing, double check that you've got a dead circuit. That always makes me feel good. And I wanted to point out that it's very important that you know which one is the line and which one is the load. So the line terminals are connected to the power coming into the outlet. So from the breaker box to the outlet, that's the line connections. And then if you have a downstream outlet that is connected in series with this GFCI, you want to put that on the load terminals. And so if you get these backwards, it can cause the GFCI to trip inappropriately. So what I would recommend is that you somehow mark the one that is on the load side, the one that's going to the downstream outlet, so you don't get them confused. So I'm just going to put a mark on that one, and I'm going to put a mark on the insulation of the wire here. That way, and you could also put a piece of tape or some other way to mark it. The other thing I wanted to point out is that you can tell that this is a 20 amp circuit because it is got the yellow insulation and 12 gauge wire. It's a little bit thicker wire, and that's designed to carry the 20 amp load. So yeah, let's get busy replacing the outlet. All right, I've got the new outlet hooked up. I've got my marked wires on the load side, and I wanted to point out, in case you don't know, the black wires are the hot wires, and so you can see those are hooked up to the hot terminals there, and the white wires are the neutral wires. So that shows there white and neutral. So you want to just make sure that that's all good to go, and make sure the ground wire is hooked up as well. And as an added little safety feature, I'm going to wrap electrical tape around these terminals. That just gives me warm fuzzies when I put it back in, that it's not going to make contact with something that it's not supposed to. And I wanted to point out something else. You see I wrapped the wires around the terminal screws. I just feel like that gives a more secure connection. I'll show you on this old outlet. Some outlets have these little holes here where you can put the wire in straight without bending it around the terminals. And some of them are even spring loaded, so you don't have to do the screw terminals at all. You just push it in and it kind of holds it secure. I would not recommend that, especially for GFCI outlets, because those can weaken over time, or you might feel like it's secure but it's actually not, or something might loosen up as you put it into the back into the outlet box. So I just recommend taking the extra effort and twisting the wire around the terminal screw like that. So yeah, now we're going to push it back into place and get everything put back together, and then we'll test to make sure it's wired correctly. Got the outlet pushed back in. We've upgraded to a metal faceplate, so that's always fun. And you can see that the red light is showing that it's tripped. So we'll hit the reset button. I'll try that again. Push that all the way in to reset it. The red light goes out. Now I'll show you this other nice tool that I highly recommend. is a circuit tester, and it shows different scenarios. It's got 3 different lights here, and so you can tell if you have issues like an open ground, if you've mixed up the wiring, or if it's correct. So it's always good to plug that in, and you can see it's got 2 lights, which is the correct wiring. So that's good. And then it's also got this button for testing GFCI outlets. So you can push that button and it causes a ground fault. And then you can see now the outlet doesn't have power at all and the red light is on. So then you just need to reset it like so, and it should be good to go. So that is how you diagnose and fix a tripping ground fault circuit. And hopefully this was helpful. And if you like this kind of content, please like and subscribe to the channel. That will help out a lot. And in the comments, let me know if you have any other tips and tricks on projects like this, or if you want to see videos on any other kind of home maintenance projects. Until next time, thanks a lot.